Why? Because that's how I like my math. Well done. This week's video question. Mr. Law's taking a break from what he does best, teaching math. Blends coffee at Tasti-Delight in Ozark, Missouri. He needs to prepare 160 pounds of blended coffee for $4.05 a pound. He plans on doing this by blending together a high-quality bean consisting of $4.75 a pound and a cheaper bean at $2.50 per pound. To the nearest pound, find out how much high-quality coffee and how much cheaper coffee he should blend. So here we go. And a perfect blend of math and coffee, because that's what mathematicians have been doing since the beginning of time, turning coffee into theorems. So I suggest we use a chart. What do we have here? We have the dollar, the amount of coffee, and the contribution to the coffee equation. I have high quality beans, I have cheap beans, and I have the total amount of beans. The quality beans, the quality beans are gonna be $4.75 per pound. The cheap beans is $2.50 per pound. What does our blend need to be? Our blend needs to be $4.05 a pound. Now we need to know the amount. Did we know the amount of quality beans? We don't. Why don't we call that Y? The cheap beans, let's call that X. Whoa! How many total pounds of beans do we need? We need 160 pounds of beans. So now we need to find the contribution of each one of these. We need to see how much money is spent on the quality beans. We take the dollar amount of beans times the amount of beans, and we have $4.75 times Y. And then for the cheap beans, we take the price of the cheap beans times the amount of the cheap beans, and that's going to be the contribution to the total price of these beans. So that's 2.5 times X. What's next? We need to find how much our mixture is going to cost. So we hope to sell it for $4.05 times 160. If we pound that out in our calculator, that's $648. So that lends us to two equations, the amount equation and the contribution equation. So I'm going to take those over here. The amount equation, X plus Y, that's going to be equal to 160. And the contribution equation, 2.5X plus 4.75y, that's going to be 648. Great. Now I have two equations and two unknowns, and I have three legitimate ways. I can graph them off the table, or I can use substitution and elimination. So let's use substitution. I'm going to solve this guy for X. So X turns out to be 160 minus Y. I'm going to come back to that in a moment, but now I want to take that and I want to substitute it into here. So to be clear, that's going to be 2.5 times 160 minus Y. And then it's going to be plus the rest of this guy, plus 475. Y is equal to 648. Great. Wait, at this point in time, some people will clear decimals, but I like decimals. Go decimals. They're dewy. And I do multiply that in. The 2.5 times the 160 is 400 minus 2.5y. And then that's going to be equal or plus that 4.75y is equal to 648. Great. I'm going to gather, collect, and combine. Gather, collect, and combine. And I'll have my 400 plus my 475 minus my 225 is going to give me 2.25y. And then that's going to be equal to that 648. Finish him. Yeah, finish him. I subtract that 400 off each side. And then over here, I'm going to have, wait for it, 248 is it when I subtract that 400 from that 648. And then over here, I still have that 2.25y. And I divide both sides by that 2.25y. And when I do, y turns out to be, wait for it, 110.2. Now, if we go back to our problem statement, it says to the nearest pound. So, y is going to be about 110 pounds, because that's where that rounds. What was y? Y was the amount of quality beans. So, we have 110 pounds of quality beans, but we need to find out how many cheap beans. So we go back up over here. Here, x is equal to 160 minus my quality beans, 110. You can see that. And then my x turns out to be 50 lbs of cheap beans. Watering it down. 110 quality beans and 50 cheap beans. Yeah. Come on, perk up.